Dear students, I have the pleasure to meet you today to deal with another examples or more examples on equilibrium of a body on a rough inclined plane under its weight. Let's go to the first example. A body of weight 38 Newton is about to move under its own weight when placed on a rough plane inclined to the horizontal with an angle whose tangent is 1/5. If this body is placed on a horizontal plane which is as rough as the inclined plane and is acted on by a force inclined to the horizontal at an angle whose sine is 4/5, so that the body is about to move. Find the force and the normal reaction. Solution. Since the body is about to move on the inclined plane under the action of its weight only, therefore, as you see in the figure, the body is placed on a horizontal plane. Its weight is downwards 38 and R is upwards. But P, which is inclined to the horizontal by an angle of measure theta, is resolved to two perpendicular components which are P sine theta and P cosine theta, and to the left on the horizontal plane we write F1, which is equal mu R, and in this triangle we draw angle theta whose opposite is 4 and adjacent is 3, then the hypotenuse is 5, to say that sine theta equals 4/5 and cosine theta equals 3/5. Then mu, as we know, mu equals tan theta equals 1/5. Then on the horizontal plane, P cosine theta equals mu R. Therefore, 4/5 P cosine theta multiplied P equals 1/4 R, and this is equation number 1. Then R plus P tan theta equals W. Then R plus 3/5 P equals 38, and this is equation number 2. After that, from 1, R equals 3P, and by substituting in 2 we can get 3P plus 4/5 P equals 38. Then P equals 10 Newton after simplifying, and R equals 30 Newton. Now let's go to another example. A body of weight 50 Newton is placed on a rough inclined plane and is acted on by a force P along the line of greatest slope upwards given that the body is about to move upwards when P equals 30 Newton, and it is about to move downwards when P equals 20 Newton. Find the coefficient of friction between the body and the plane. Solution. As you see in the figure, W is acted downwards, which equals 50, and factorized or resolved into two perpendicular components, 50 cosine theta and 50 sine theta, and P is upwards the plane, the inclined plane, and mu r is down the inclined plane, but r is perpendicular to the plane. Case number 1. The body is about to move upwards. If the body is about to move upwards here, then mu r is downwards. Therefore, P, which is upwards, equals downwards, which is mu r plus W sine theta, or 50 sine theta, equals 30 equals mu r plus 50 sine theta, and this is equation number 1. Also, r equals W cosine theta, and here W equals 50. Therefore, r equals 50 cosine theta, and this is equation number 2. After that, we can say that P equals mu r plus W sine theta. Therefore, 20 equals mu r plus 50 sine theta, and this is equation number 3. Also, r equals W cosine theta, then r equals 50 cosine theta, and this is equation number 4. By adding 1 and 3, then 50 equals 100 sine theta. Therefore, sine theta equals half, i.e., and this means theta equals sine 30, or theta equals 30 degrees only, not sine, 30 degrees. Sine theta equals half means theta equals 30 degrees. And by substituting in number 2, we get r equals 50 cosine 30 equals 25 root 3 Newton. And by substituting in equation number 1, we get 30 equals 25 root 3 mu plus 50 times half. Therefore, mu equals root 3 over 15. Now, let's go to a new example. A body whose weight is 20 Newton is placed on a rough plane inclined to the horizontal by an angle whose tangent is 4 over 3. If F1 is the least force if applied along the line of greatest slope upwards, and if F is the least force applied along the line of greatest slope upwards, the body is about to move downwards. F2 is the least force if applied horizontally, the body is about to move downwards. If F1 equals F2, then find the coefficient of friction of the rough plane and the magnitude of any of the two forces. Solution. As you see in the figure, we draw a body placed on an inclined plane. Its weight is downwards equals 20, which is resolved into two perpendicular components, 20 cosine theta and 20 sine theta. But on the inclined plane, we write F1 and mu R1 upwards, and R1 is perpendicular to the inclined plane. Therefore, case number 1, the body is about to move downwards. Then F1 plus mu R1 equals W sine theta. Therefore, F1 plus mu R1 equals 20 times 4 over 5, which is 12 or 16. Therefore, this is equation number 1. Also, R1 equals W cosine theta, and here R1 equals 20 times 3 over 5, which is 12 Newton, and this is equation number 2. Case number 2. As you see in the figure, we draw W downwards equals 20, resolve it into 20 cosine theta and 20 sine theta, and F2 parallel to the horizontal, and resolve it into two perpendicular components, F1 or F2 cosine theta and F1 sine theta. Therefore, case number 2, the body is about to move downwards. Then F2 cosine theta plus mu R1 equals W sine theta. Then 3 over 5 F2 plus mu R2 equals 20 times 4 over 5. Therefore, equals 16, the final answer. And this is equation number 3. Also, R2 equals W cosine theta plus F2 sine theta. Now, R2 equals 20 times 3 over 5 plus 4 over 5 F2, and after calculation you can get the following step. R2 equals 12 plus 4 over 5 F2, and this is equation number 4. Now, F1 equals F2 equals F. Therefore, by substituting from 2 in equation number 1, you can get F plus 12 mu equals 16, and this is equation number 5. By substituting from equation number 4 in equation number 3, you get 3 over 5f plus mu, open bracket, 12 plus 4 over 5, close the bracket, equals 16, and this is equation number 6. From 5 and 6, you can get 3 over 5f plus 12 mu plus 4 over 5 mu f equals f plus 12 mu. Therefore, 4 over 5 mu f equals 2 over 5 f, and by dividing by f, then we can get mu equals 1 over 2. 1 over 2. By substituting in equation number 5, then f plus 12 times half equals 16, therefore f equals 10. Now let's go to a new example. Example number 1. A body of weight 12 gram weight is placed on a plane inclined to the horizontal at an angle whose tangent equals √3. A horizontal force F of magnitude 10 gram weight is acting upon the body. Find the two components of each of the weight and the force along the line of greatest slope of the plane and the perpendicular to it. Solution. Here in this triangle, the opposite of angle alpha is √3, the adjacent is 1, the hypotenuse is 2, where tan alpha equals √3. Therefore, cosine alpha equals 1 over 2 and sine alpha equals √3 over 2. Then, as you see in the figure, the weight of the body is 12 resolved into two perpendicular components, 12 cosine alpha and 12 sine alpha, parallel to the line of the greatest slope, and the force F, which is drawn parallel to the horizontal, also resolved into 10 cosine alpha upwards parallel to the line of greatest slope and 10 sine alpha. Therefore, the components of the weight are 12 times 1 over 2 equals 6, and 12 times √3 over 2 equals 6 √3. This is the first required. But the components of the force F, as we said, are 10 cosine alpha and 10 sine alpha, which are 10 times 1 over 2 equals 5, and 10 times √3 over 2, which is 5 √3 gram weight. Equilibrium of coplanar forces meeting at a point. Equilibrium of a body under action of two forces. If a body is equilibrium under the action of two forces only, then the two forces are equal in magnitude. Number 2, the two forces are opposite in direction. You know this knowledge. Number 3, their line of action are on the same straight line. For example, if a body is suspended by a light string, it balances under the action of two forces. The weight W, which acts vertically downwards. Number 2, the tension in the string T, which acts vertically upwards. Therefore, W equals T. Number 2, if a smooth body of weight W rests on a horizontal smooth plane, then the body acts on the plane with pressure force or action, which represents the weight of the body. And the plane acts on the body with a force, which is reaction, which is equal in measure the weight of the body but opposite in direction. Therefore, R equals W. And in this case, any small force not vertical makes the body move on the plane. Let's go to another example. A body of weight 76 Newton is about to move under its own weight when placed on a rough plane which inclined to the horizontal with an angle whose tangent is 1/4. This means tan theta equals 1/4, as you know. And if the body is placed on a horizontal plane which is as rough as the inclined plane and is acted on by an upwards pull in a direction inclined to the horizontal with an angle whose sine is 3/5, so that the body is about to move, find the magnitude of this force and the normal reaction. Solution. Since the body is about to move on the inclined plane under the action of its weight only, therefore, as you see in the figure, we put the body on a horizontal plane, R upwards, and its weight W is downwards. T inclined to the horizontal at an angle of measure theta, and we resolved it into T cosine theta and T sine theta, two perpendicular components. And in the horizontal plane, T cosine theta is to the right and F1, which is mu r, is to the left. And in this triangle, if tan theta equals 3/4 opposite over adjacent, then the hypotenuse is 5, and so we can find sine theta 3/5 and cosine theta 4/5. Then, since lambda equals tan theta equals 1/4, then on the horizontal plane t cosine theta equals mu r. Therefore 4 over 5t equals 1 over 4 r, and this is equation number 1. Then r plus t tan theta equals w. Therefore r plus 3 over 5t equals 76, and this is equation number 2. Then from 1 r equals 16 over 5t. By substituting in equation number 2, then 16 over 5t plus 3 over 5t equals 76. 16 plus 3 equals 19 over 5t equals 76. Therefore t equals, after simplifying, 20 newtons, and r equals 64 newton. Dear students, this example leads us to the end of our program today, and until we meet again the next week, I hope you enjoy our lesson today. I hope you all success. Thank you and goodbye.